Let's verify whether the set G here represented by Z8 is a set under, is a group rather, under the operation addition modulo 8. So we have this Cayley's table here. We're going to complete it later. But of course, we are going to start with the idea that our set G, which is equal to Z8, is non-empty. For this, since the operation is addition modulo 8, it means we're talking about the remainders of the numbers when divided by 8. And the remainders are actually start with 0. That is actually if we have 8 divided by 8, you don't have a remainder. We have 1, 2, 3, 4, 5, 6, and only until 7. Because if you have 16, say for example, or of course, if you have 15, the remainder is 7. If you have 16, the remainder is 0 because 16 16 is divisible by 8. So we have these elements. This means that it's very clear that our set is a non-empty set. The next here is to examine whether this what do you call this one? This operation is closed, or I mean, our set G is closed under the operation addition modulo 8. So let us all have this case table, but since we already using star here, let us make the star be addition modulo 8, so that we could use star as we go through to the next few portions of this proof or this video. So we were going to examine this case table. We're going to operate them using addition modulo 8. That means for the first entry, 0 plus 0 is 0. 0 modulo 8 is 0. Okay? 0 plus 1 is 1. That's modulo 8. 0 plus 2 is 2. 0 plus 3 is 3. 4, 5, 6, and 7. And all of these are still the answers when you have modulo 8, because we have, say for example, 0 plus 7, that's still 7. The remainder when divided, the 7 by 8. For our first column here, we also have the same concern. 1 plus 0 is 1, 2 plus 0 is 2, 3 plus 0 is 3, 4 plus 0 is 4, this is 5, this is 6, and this is 7. Now let's complete slowly. We have 1 plus 1 is 2 modulo 8. 1 plus 2 is 3 modulo 8. 1 plus 3 is 4 modulo 8. 1 plus 4 is 5 modulo 8. 1 plus 5 is 6 modulo 8. 1 plus 5. 1 plus 6 is 7 modulo 8. 1 plus 7 is 8. Modulo 8, that's actually 0. Okay? So you will not be getting 8 here until 7 and you return to 0. The next row, we have 2 plus 1 is 3 modulo 8. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6 modulo 8. 2 plus 5 is 7 modulo 8. 2 plus 6 is 8 modulo 8. That's actually just 0 modulo 8. 2 plus 7 is 9 modulo 8. You have here 1. Next, 3 plus 1 is 4. This is 3 plus 2 is 5. 3 plus 3 is 6. 3 plus 4 is 7. 3 plus 5 is 8. That's 0 modulo 8. 3 plus 6 is 9, so 1 modulo 8. 3 plus 7 is 10, that's 2 modulo 8. Next, 4 plus 1 is 5 modulo 8. 4 plus 2 is 6 modulo 8. 4 plus 3 is 7 modulo 8. 4 plus 4 is 8, that's 0 modulo 8. 4 plus 5 is 9, that's 1. 4 plus 6 is 10, so that's 2 modulo 8. And 4 plus 7 is 11, that's 3 modulo 8. Continue. 5 plus 1 is 6. This is 7. 5 plus 3 is 0. 5 plus 4 is 1 modulo 8. 5 plus 5 is 2. 5 plus 6 is 3. 5 plus 7 is 12. That's 4 modulo 8. Probably you could see a trend, but just for careful consideration, let's do it step by step. 6 plus 1 is 7. 6 plus 2 is 0. 6 plus 3 is 9. That's 1. 6 plus 4 is 10. That's 2. 6 plus 5 is 11, that's a 3. 6 plus 6 is 12, that's 4. And 6 plus 7 is 13, that's 5 modulo 8. And for the last row, you have 7 plus 1 is 0. 7 plus 2 is 1 modulo 8. 7 plus 3 is 2 modulo 8. 7 plus 4 is 3 modulo 8. 7 plus 5 is 12, so that's 4 modulo 8. 7 plus 6 is 13, that's 5 modulo 8. And 7 plus 7 is 14, so that's 6 modulo 8. Using all of these entries in our Cayley's table, we could see that the elements or the results are just either 1, 0, 1, 2, 3, 4, 5, 6, and 7, and they are also elements of our Z8 or our G. This would mean that the closure property holds. Okay. Now that we have established closure property, we can now proceed to the first condition for a group, and that's actually G1. We are going to verify whether star is associative in Z8. Now, there are a lot of ways to prove associativity. You can even pick items or elements or examples from this case table. But of course, again, one or two examples is not necessarily enough for us to show associativity, because there might be some one counterexample in the process. But I'm quite sure that for this, it's associative because of this reasoning. We have here, since addition. Let us focus first on addition. Since addition, okay, is associative in general. And we could see that the elements of our Z8, 0, 1, 2, 3, 4, 5, 6, and 7 are also elements of our Z, which is the set of integers. Okay? And addition is actually already associative in the set of Z, or the set of integers. This would mean that the 0, 1, 2, 3, 4, 5, 6, and 7 is just a subset of the set of integers. This would mean that this addition is also associative in our Z8. But more specifically, we can say here that we can say that addition is also associative in Z8. Again, with that reasoning that our Z8 is just a subset of Z. At the same time, if we're going to consider star, which is addition modulo 8, whatever will be the result of A, star B, star C, or let's just use here the plus, because we're talking about addition without the use of this first. So we can say, so A plus B is just equal to A plus B plus C, which is the general associativity for our addition on a set of integers. This would mean, let me use other color here. Okay. This would mean that the result of this A plus B plus C, okay, if we're going to have it equal to D, this is also the same as A plus the grouping B plus C, right? So they have the same result of D. Under star, since they already have the same result, the A star B star C must also be the same as A star B star C, because this will just use the value of modulo 8 on the sum of the three elements, to which we already identified as the same. With this, we can say that star is associative in Z8 by invoking the associativity of the set of integers in general. Okay, I hope that's already enough for the G1. For G2, we are going to look at the idea of existence of our identity element. So let me copy the entire Cayley's table here so that we will not be returning to it later. Let's say copy. Okay, place it here, because we will be using this Cayley's table as we are going to have our G2 and G3. Again, don't forget that the operation is star 0, 1, 2, 3, 4, 5, 6, and 7 here. 0, 1, 2, 3, 4, 5, 6, and 7 here as well. So for our G2, what we are trying to do here is, if we're going to let A be element of our Z8, we need to find certain E, which is also element of Z8, such that we could satisfy this condition. A star E is equal to E star A equal to A for all A element of our Z8. We have the same identity for all. Okay? So what we're looking here is the result of an operation that when a certain element is multiplied to other values, we will get the value of this element itself. And what is that value that we're multiplying for? Okay, we could only get this by looking at our first row and first column, because if we have 0 star 0, the result is just 0. That's for 0 alone. If we're going to use 1 star 0, it's just 0 times, or not times, star 1 equal to 1. Meaning, if we're going to operate 1 with 0, no matter what is the placement of 1 and 0, we'll still get 1, the 1 itself. If we're going to have 2 operate with 0, or 0 operating with 2, you will still get 2. 3 operate with 0, 0 operating 3, you will get 3 here. That's also true. 4 star 0, 0 star 4, you will get 4. 5 star 0 is 0 star 5 equal to 5. If you have 6 star 0, that's just equal to 0 star 6. That's 6. You can look at our Cayley's table here. And of course, if you have 7 star 0, 0 star 7, that's 7. That is because, since our operation is addition modulo 8, we also have the same identity element for addition in general. And that is actually the value here. Okay, these values are not including that first one, that one. Because this is the value that when operated with other numbers, the result will be the actual value of that second number. This is, we can say that our identity element here is 0, and since 0 is an element of Z8, we can say here that G2 is satisfied. Okay, G2 is satisfied for this because our identity element, which is true for all elements in our Z8, can also be found in our Z8, which is actually 0. Okay, with this, let's proceed to our G3. G3 here, if you're going to let A element of our Z8, we need to find A inverse, also element of Z8, such that if we're going to operate A and A inverse, is just equal to A inverse star A equal to E, which is 0. In other sense, we're going to look for the inverse of a certain element that when operated with that, our resulting here is 0. In short, look for 0 in our Cayley's table. 0 is here, 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 and here. Those numbers that are operated that will result to 0 are actually inverses of the other. We have, of course, 0 star 0 is 0. We also have 1, but together with 7. This is 7. 7 is the same as 7 star 0. Okay, I said star 1 rather. Star 1. Okay, is equal to 0, the identity. We still have more. Okay, yeah, I hope that my space here enough for you to see our Cayley's table. For 2, here is 2. This is actually 6. Is equal to 6 star 2 as well, because 6 and 2. Also 0. For our 3, star 5, which is the same as 5 star 3 equal to 0. For our 4, 4 star 4 is 0. We also have 5. I already have 5 here, by the way. Sorry. This is our 5 star 3. We have here. We have 6 star 2 and 7 star 1. So what are these values now? Okay. The values of the inverses are these portions here. Okay. For these items, their inverse are this. For this, you have this inverse. Here and here. And what does this tell us? Let me move here. That would mean that the inverse of 0 is 0 itself. The inverse of 1 is 7. The inverse of 2 is 6. The inverse of 3 is 5. The inverse of 4 is 4 itself. The inverse of 5 is 3. The inverse of 6 is 2. And the inverse of 7 is 1. And when you look at all of these values, 0, 7, 6, 5, 4, 3, 2, and 1, all of this here are still elements of our Z8. This means that our G3 is satisfied because all the inverses are still elements of our Z8. So with G3 satisfied now, and G2 satisfied earlier, and our understanding and analysis on associativity, we can now say that our set here, let me use this color, our Z8, okay, is a group under star, which is defined as the addition modulo 8. So here's the claim at the final result here. Z8 is a group under star because we have satisfied all these conditions. And this is how we do it for this item. Thank you for watching.